So let's solve the first problem of practical kinematic. And you see about a racing car, start from rest. So that is the initial condition that we need to take into care of. And accelerate it uniformly. This means that the constant acceleration. The time given is 10 seconds to reach to point B, which is the distance is 1200 feet. The question is what is the tangential, AT, and the normal component, AN, of the acceleration. And there are two scenarios. The first one is just before C pass B here, and just after C pass B. So just before C pass B, so it's on the line AB, it's straight. So the motion in here, that will be a rectilinear. Motion. And just after C passes B on the curved track, so that will be the curvilinear motion. We start what is given and try to find relationship where they give you the uniform acceleration, they give you the 10 seconds, which is the time, and the distance 1200 feet, which he asked. So we want to find out the relationship between time, acceleration, and distance. So we start with acceleration, and in this case, uniformly accelerate, so it will be constant. So the next, we take the integral with regard to time for the acceleration. So we have v, velocity, equal to a dt integral. And a is constant, so we can have that equal to at dot c1, the first constant. And then if we take another integral, we will get the distance s, and because that's what we need to looking for, because they give us the distance between A and B is 1200 feet. So s, we can take integral v dt, and if we replace that with the at plus c1 dt, so a again a constant, so at it will be 1/2 of a t square plus c1t and plus another constant c2. And the constant c1, c2, we will get it from the initial condition. So initial condition in this case start from rest. So as you can see, at time equals 0, what we have is s, the distance equals 0 because it's at A. And then the velocity start from rest. So for sure, we have it velocity equals 0. So let's plug that into the equation, the velocity. So you can see for the velocity equation, I have v equals 0 at t equals 0. So a times 0 plus c1. So from that, we can have c1 equals 0. Okay. Yep. And then we also have s equals 0 equal 1/2 of a 0 square plus c1 0 plus c2. We also have c2 equals 0. So what does that mean? We can have the equation for the distance can be rewritten as 1/2 a t square c1 0 c2 0. So we're not involved in that equation. And we the problem, as you can see, they give us the time 10 seconds to reach 1200 feet. So from that we can plug in to find out the acceleration here. So as you can see, at t equal to 10 seconds, we have s equal to 1200 feet. So plug in that equation, we have 1200 equal to 1/2 of a times 10 squared. And from that we can have a acceleration equal to 24 feet per second square. And that way is either acceleration for the rectilinear motion, only one component just before C pass B, and it are AB on horizontal line, so you can see the acceleration in your vector. So you can put the vectors, the direction, so we can have a vector need to include the magnitude 24 unit feet per second square. Point of application, you see acceleration at B, and then direction is horizontal. So that is the first answer, so we can underline that. Okay, so that the first scenario there. And now after C passes B, that will be a curvilinear motion. So in the curvilinear motion, we can have two components that we already know. So let's talk B. So we have A for point B. In that case, we can have that a tangential component of point B, right? And then normal components of point B. And just before C reaches B and just after C passes B, the tangential components remain unchanged. So we still have a tangential component still the same, equal to 24 feet per second square, and same as the one we do above. And in terms of the normal components, we already have equation is an b equal to vb square overall. And as v equal to 80, we can plug in v equal to 80 on top of the equation we have here, because c1 equals 0, so you have that. Yeah, so we can have an a already 24, so you can plug in 24 times t 10 square total divided by rho. Rho in this case is the radius of the curve track, so it will be 400. So from that we can get equal to 144 feet per second square. In terms of direction, it always directs to the center. So as you can see, the center of this curve track is somewhere right there. So the direction, it will be vertical going down at point B. So bottom line, we have two components, so we can have the general acceleration at point B just after C pass B, it equal to 24, which is the tangential component, and that will be horizontal, go to the right, and then the normal component 144 feet per second square, and just go in now to the direct to the center. So that basically the solution for problem 1 of practical kinematics.